All right, so I want to take a look at a couple questions on the review packet. This is some stuff that goes back to specific heat and calorimetry. So this is number 4. I'm actually going to put 4 and 5 on the same video. So if you want to see 5, just fast forward through this, and then you can take a look. Okay, so what we have here says calculate the mass of a sample of lead, and it gives the specific heat of lead being 0.160 joules per gram degree Celsius when it loses 200 joules cooling from a temperature of 75 degrees Celsius to 42 degrees Celsius. Okay, so we've got a couple things here. First of all, it wants to know what the specific heat is. Oh, I'm sorry, it wants to calculate the mass. All right, so how much of this do we have? Specific heat, okay, what specific heat represents is a relationship. All right, so specific heat is going to give us some number. In this case, it's 0.160, and that's joules of energy for every gram of that substance and for every degree of temperature that it changes. Okay, and so in this case, we're looking for thank you. See you later. So in this case, we're looking for the mass. Now, this is our ratio that's already given. So what we can do is we can set this equal to the quantities that we have. So we're given something that loses 200 joules. All right, so 200 J. And we don't have the mass, so the grams is our unknown. And then we're going to divide this by our temperature change. So our temperature change is final, which is 42 minus 75, and that gives us a temperature change of positive 33. Okay, so 33. So this 0.160 will equal, okay, the 200 divided by the mass and divided by the temperature. Okay, so there's our figures broken out. Whenever we're given the specific heat of something, okay, we can then set it equal to a formula, which is basically the units, okay, joules, grams, and temperature, okay, the degrees temperature change, and solve for our mass. Okay, so when we have a situation like this, we're going to multiply both sides by G, or mass, and then we're going to divide both sides by 0.160. So our mass will equal 200 divided by 0.160 times 33, and we get a mass of 37.9 grams. And then let's also make sure we're putting the right label on that, and that is a PB. Okay, so that's using specific heat to determine the mass of a substance that we have. Number 5 looks a little different. Okay. Number 5, we have calculate the energy required to take 450 grams of water from 27.5 to 102 degrees Celsius. This problem is a little bit more involved because we have multiple steps. First of all, we have to look at what's going on with the water. So we're at 27.5 degrees Celsius. At this temperature, water is a liquid. We're going to take this water up to 100 degrees Celsius, but we're not going to change it into gas. So we have a delta T here that we have to look at, and that delta T is 72.5 degrees Celsius. So we're going to heat water up to that temperature. So we're going to calculate how much energy does that. Now, we're going to come back to that in a minute. I'm going to do the next part of this, and that is the where we take that water and we turn it into steam. Because we're going from 27.5 up to 102, we're going to take it through a phase change. All right, so the second step will be our phase change, and we're going to vaporize, okay, which is a liquid to a gas. Okay, And then our third phase, or third step here, it's not actually a phase, is going from 100 degrees Celsius to 102. All right, so that is our vapor being heated. All right, and that is a delta T in this step of 2 degrees. Okay, so we have two temperature changes, one of the heating of water up to 100, the other one going from 100 to 102, and then the step in between, which is our phase change, which temperature doesn't change, where we have liquid going to a gas. From here, it becomes fairly simple, okay? We are going to we're going to use the specific heat of water for the first step, because we're just heating water. This is C of H2O, and it's assuming that it's a liquid. So we're going to take 4.184, and this is joules per gram degrees Celsius. So when we have something that looks like that, and we are given a temperature change here, so we're going to multiply that by 72.5 degrees of temperature change. And then we're also going to multiply that by the mass. And we'll see the units of temperature and mass divide out. So we had 450 grams. So grams divides out, grams divides out. Okay, so when we calculate this out, the first heating of the water before we get to the phase change, this is going to equal 136,503 kilojoules. The second part here, we're going to look at the phase change, and with phase changes, this has a unit of 2260 joules per gram. Remember, we don't have a temperature change, therefore we're not going to have a temperature that we put in our calculations here. We're just going to multiply the heat capacity by our specific mass that we have, and that gives us 1017000. And these are, actually I put this in here correctly. This should be in joules. This is also in joules. And then the last one here, the heat capacity, or the specific heat that we have for vapor, okay, or steam, that is our third value, and that's 2.006 joules per gram per degrees Celsius that we change. So we're going to multiply that by our 450 grams, and then multiply that by the by the 2 degrees of temperature change that incurs. And that gives us a number of 1805.4 joules. Okay, so we've got energy coming required from these three steps. Okay, when we sum them, the total of the three is going to yield 1155308.4. And sig figs, we're going to go 3 sig figs because we have 3 digits here in our value. And it went up to 102, 3 digits there. So this will become 116 followed by 4 zeros, or 1.16 times 10 to the negative 6. And that's in joules. Okay, so that is what this looks like, especially when we do something for a temperature change. Sorry, there's your answer down there. It was below where the screen was. All right, so that's how we do 4 and 5.